Hi, welcome back for another 6 Caillou challenge called Does My Number Look Big in This? A narcissistic number, or Armstrong number, is a positive number in which the sum of its own digits, each raised to the power of the number of digits in a given base. In this kata, we will restrict ourselves to decimal, which is base 10. For example, consider the number 153, which is narcissistic because you have the three digits are 1, 5, and 3. And remember, the length is 3. There's 3 digits in that number. So all of the digit values are being raised to the third power. And if you sum those, 1 to the third plus 5 to the third plus 3 to the third, that'd be 1 plus 125 plus 27. It equals 153, which is the original value. And then they show you an example 4-digit number, which isn't. You can see the same breakdown. The challenge, your code must return true or false, depending on whether the given number is a narcissistic number in base 10. This may be true or false in your language. Error checking for text strings or other invalid inputs is not required. Only valid, positive, non-zero integers will be passed into the function. Of course, you're welcome to do that error checking if you want to treat this and get in the habit of coding like you would in real life, but it's not necessary for this challenge. I did verify that. So why don't you go ahead and pause the video, think about it a little bit, and have a go. Come on back when you're ready, and then I'll go into my solution. So the first thing I want to do is, in order to get the size of the number, how many digits it contains, that is, and to access each of the individual digits, what I'm going to do is convert it to a string. I'll say string, let's call it val text equals value to string. And by making a string out of this, I can just say val text.length to get how many digits are in it, and that'll be the power that I use. And then I can also sort of go over this collection of characters. That's what a string is, a collection of characters, to process each digit individually. And to do that, I'm going to use a link method that I will show you. Before I do that, let's bring in system link namespace before I get in trouble. Good. And then next we will go over that link method. So I'm going to bring you to sum. Let me just go to the top so you can start from the beginning. A numerable sum does what you think it does, computes a sum of a sequence of numeric values. Now you'll notice that they got these for all these different kinds of integral types here in 64, which just means a 64-bit integer. The one we're used to is int32. They have single, must be single precision, double precision, decimal, double. And then I want you to note that these ones just sum up your collection. So the collection already contains integral values, or not necessarily, I should say numerical values, because it could be doubles, right, and singles and decimal. So they're not necessarily integers, but they're numerical values that when you tell the computer to add them, it makes sense. Consider or contrast that with the situation where you had, characters and other things, strings, and you wanted to add them. We know that usually means concatenation, but in terms of numbers, it's very straightforward what to do with those types. Or if you had a custom type, it might not be clear what it means to sum them. And so we look for more overloads here, and we notice that some of these have a collection that you're going to sum. And then they give you, they have these function delegates here, which you can use to transform each element. See that language here in the description? By invoking a transform function on each element of the input sequence. And so that's what I want to do, right? Because I made my number into a string, and so I'm going to get each digit as a character, and then I want to transform that character into its corresponding numerical value, which I can then work with in terms of performing these math operations. So that's what I'm going to do. You can click exactly on that overload. It'll take you to the detail page. You'll notice it returns an integer because it's summing up. Our transform function is going to convert into integer values, and that's why it's returning an integer as well. You're adding a bunch of integers, 32-bit integers in this case. And they have an example here. This one's actually using double, but you can see how they have this package class with a weight that has a numerical value. And so instead of just hitting sum, it might not be clear from a package what sum means, but you specifically tell it, hey, with each package object in this packages collection, you're accessing the weight field. So it's transforming, to use the language that we just read, it's transforming a package into a weight, which is a numerical value, and then it can add up all those doubles, and that's why the return type is a double here. So we're doing the same thing, it's just going to happen with integers. So that's good. We can make our sum that way. So let's go back. So we can say val text sum, right? And so what is each item in val text? Well, it's a digit. You could call it, I know I usually use ch for my variable names when they're characters. I'll go with digit here. And so each digit's going to be a character. Do you remember we've done this in other videos? How do we convert a character to its numerical value? Well, one way you can do that is you can say that number minus the character value for the number 0. And if you want a quick refresher on how that works, you just consult your ASCII table. We'll find 0, the 0 character in it. See, it's right here. And it's got a decimal value of 48. So the idea is, let's say we had a number like 2 that we got in our input. 2 has a value of 50. So that statement I just wrote would take 50 minus 48, which is clearly 2. And you can see that is 2, the exact value that we wanted. So that's sort of how that works. So that's good. That gives us, that sort of converts the character to a number for us. But that's only part of the problem, right? That gives us the digit we have right here. The second part is we have to raise each digit to its corresponding power. And maybe you recall that the math class has a math pow function for power, where you provided the base and then the exponent value. So what would the exponent value be here? Well, it's the number of digits in your original number, right? So we could say valtext.length. Close that. And then finally, this should give us an integer value. Yeah, I can convert this to an int, because if you go to the docs for power, it's going to return a double. So what I can do is just cast each of these calculations to an integer, and then it will return an integer. And so what's left at this point? At this point, you've summed up and you've gotten to the point where you have this answer value here. So how do you check that? You say return value is equal to, let's call it sum. I forgot to put that in up here. We'll say int sum equals valtext sum. And so, yeah, something like this. I'll go ahead and run it. I didn't expand the coding area because the amount of code I wrote was so small. Okay, the name math does not exist in the current context. You know what the problem is here? Well, we didn't define this pow function, right, or math. So we have to bring in the corresponding namespace. If you recall, that's using system for math. That was a valid complaint. So good, we hit the green. I'll attempt it. And overflow. Okay, good. So notice how we hit a couple successful tests. Okay, great, great. Good stuff going on there. And then we hit these random tests. Let me see if I can get, they're not going to show it. Let me sit down here. What you could do is, if you didn't know what was going on, you could do this. You could say console write line and say something like input. We just want to see what we're working with here. Run test again. Or I think test was all clear. I'll hit attempt again. So what happened with the, look at the previous tests. Oh no, I didn't mean to go back. Really? You did that to me? Okay. Wow, that's very unfortunate. I'm sorry I spoiled the result for you here. It's not much to, what I was trying to show you was that with the later tests, the numbers were getting bigger, right? And do you remember how I originally, with this sum line over here, I had used a regular int. And so what happened was when you raise all those digits to those powers, it gets really big and it doesn't fit inside of a 32-bit integer. So what you can do is resize to an int64 and then your answer will fit. So if you wanted to do that, string val text equals val to string, then you could say, you don't need the length bit here. You can if you like, but it's not necessary. We could say int64, right? Sum equals val text dot sum. I use ch here. I like digit a little better. And I'll say, notice how now I'm converting it to an int64. I'm making the types match. And I'll say math pow. We take our base, which is digit minus the character 0, and to the size val text dot length. That'll give us our total sum, and then return sum equals to value. That was the definition of narcissistic, right? The sum has to be equal to the value. So when I do it this way, oh sure, that's fair. I got to bring in my using statements again. Val does not exist in the current context, so I put val instead of value. Namespace in 64 couldn't be found, and that's probably the same for, let's bring in using system. Test, and sum, I need to bring in link, right? So look, string does not contain a definition for sum. We know that we took sum from system link. Let's do that. Pass, hit the attempt. Very good. So yeah, now you notice those tests that failed before. If you want, you could put that console print line there if you want to see the larger values. But yeah, sorry I spoiled it for you there. I got a little fumble fingered on my MacBook here, still getting the hang of that. But I think it's clear how this goes down. So I'll go ahead and submit mine like this. Probably lots of similar solutions out there. String, yep, they converted to a string and they summed just like we did. They just wrapped it up on one line, right? They took their sum statement here and just said equals value right at that point. That's fine. That's one less line. And feel free to look through the rest of these. You can see a different link method here, select, that they're working with. We know that is used to transform elements into it projects them into a new form, right? But you can see the same kind of thing, math power. Feel free to look through the rest of these. This is interesting, right? So yeah, I'll take a look too. You do the same. You know where to find me if you have questions. Otherwise, thanks for watching. I'll see you in another one.